My name is Alek, and today I will be talking about Kotlin Multiplatform in action. So before we start, I would like to ask how many iOS developers we have on the room. And Android guys? All right, so let's like say 50-50. And how many of you have chance to actually work with Kotlin Multiplatform Mobile? All right, cool. Nice. All right, so the plan for today is simple. Let's say I don't want to hold you from the networking. So we'll go through the why you might be interested in using this one. Actually, what is Kotlin Multiplatform and how to start. I'll go quickly through that because in these days you can ask AI and it will provide you this information. But the majority part of this presentation will be about example of how you might tackle like task of implementing a new screen in your application to use the Kotlin Multiplatform, and then some tips and tricks and maybe gotchas, and if we have time, question and answers. Okay, so why I'm here? So I have let's say 6 years of experience sharing business logic between iOS and Android. I'm an iOS developer, but before Kotlin Multiplatform, I was working at Fabulous, which was like it is right now still going the Paris startup, and there we use Java for sharing business logic between iOS and Android using J to Objective-C. Have you heard about this one?
Only because it's
Okay, so it's like a super obscure tool from Google, and it actually translates Java to Objective-C, and then you can compile the static library to iOS. So it was, you can imagine, fun time working with this one. But then I moved to Beekeepers, a Swiss company, and then we had the chance actually to use something new. And stepping from Java to Kotlin was really like a night and day for me because the experience is much more nicer. And then I would like to also share this with you. And also, last but not least, Pavel nudged me a little bit to share this with you. So it's my, like, let's say, payback for all the open source or community I use. So it's something that I would like to share with you guys today. So why you might be interested in actually listening to me talking about this? So whenever you have two project with two clients, iOS and Android, developed side by side, right? You probably face the problems with duplicated logic, right? You may have also inconsistency bugs between two platforms. Something works differently, and when you have a new features, you always have to sync between two teams to make sure that it works the same way, right? And it's most likely the manual task to do all the syncing, all the talking. So in all like too long didn't read is basically we don't like to repeat ourselves, right? And if you've been long enough in the mobile development world, you know that the cross-platform development is sort of like a holy grail. Everyone is talking about this since ages. We are talking this about right now. So there are a couple of options out there. I guess the most like hot or most attention has Flutter by Google. It uses Dart, so you have to drop Swift, you have to drop everything you do, most likely just go all in. We have also React Native. We have I think Xamarin is now called .NET MAUI. I'm not sure if I'm pronouncing this well, but anyways, we have Kotlin Multiplatform. You can also go with C++. I guess if you are brave enough. I think Dropbox and PS PDF Kit was doing this, if I recall correctly. And you can also be wild and go with J to Objective-C. It was you can ask me about this during the networking phase because it is really nice tool, and it was already abandoned by Google. So you're all on your like by yourself using this one. So that might be a little bit of obscure tool. So obviously we are here to talk about KMM. I'm not associated with JetBrains in any means, so I'm not selling anything. I'm just representing my experience and opinion about that tool, right? So at Beekeeper we had like two clients, as I mentioned at the beginning. And we were thinking about reducing this duplicating logic to make us move faster when we have new features. And we were like running discoveries how we could share the logic. So Flutter was one of the solutions that we were thinking about. But since we have already Kotlin developers, we have Kotlin code, we decided that it's a like smoother, let's say, a segue to sharing business logic. So I guess when you already have a Kotlin code in your project, it's definitely something that you can consider. If not, then I hope that sooner rather than later your Android team will move to the Kotlin because this is what we do with Objective-C, right? We also migrate to this. Not sure if anyone uses Objective-C here. All right, maybe I'm living in the sheet. All right, so the Objective-C is like an old programming language for iOS. All right, I feel old now. All right, so just very quickly, because this you can find anywhere. I don't want to just like bore you with this one. Basically, Kotlin Multiplatform is a technology from JetBrains. It's open source and utilizes Kotlin native. So basically there's like a Conan compiler which takes care of all the translations. It basically compiles to the bytecode so it can run on different platforms. And what is really important here is that it goes from Kotlin through the Objective-C, and then you import this to the Swift. So you have to be aware, for example, when you define in Kotlin like default parameters for constructors, that won't be propagated to the iOS world because in Objective-C we don't have it. So there are a couple of things that you have to be aware, or maybe also like generics and things like that. So there are some definitely drawbacks, but there are tools that you can mitigate that. So I'll cover that later on. But what is really cool about this one is that you are not actually forced to, go all in or share UI, whatever. You can have like 3 use cases here. You can just share like a small piece of logic. You can share share view models and keep the UI native. And right now you can also go all in and write the whole application in KMM, because there's a composed multi-platform UI framework that is currently on alpha on iOS. However, you can of course do this, right? So some examples what can be shared is like view models in the popular design patterns. You can have an API calls inside of this shared code using Decatur. This is a nice library from JetBrains. You can even have like a persistence layer. Realm and SQLite has KMM versions, and as I mentioned, you can go with UI. Their links are in the slides, so we'll be sharing later, so we can catch this up. So how to start? If you will say, okay, I want to try to do this in my project. So there are 2 paths. Obviously, one is for existing projects. One is when you are starting today, let's say. So you're lucky you. So let's cover the let's say more realistic case when you already have a project. So I guess the easiest way would be to use the wizard from the Android Studio and just kick off the new new multi-platform project and just grab the shared code and move it to the separate repository and then link it to your iOS and Android project as a Git submodules. Do you know what Git submodules is? Someone? Yes. Okay. Cool. So then on the iOS side, it's really easy to integrate because what you have to do is just to add a Gradle task in your build phase. And it's really small, but basically framework search paths needs to point to this framework that is going to be built. So then you end up in the structure where you have iOS and Android project that links to this shared repository. So there in this red box you have all your like shared view models and whatever you like. When you have a new project, then you basically go with this wizard from the Android Studio and go with the Kotlin Multiplatform app, and then it will build all the shared code, Android app, and Xcode app, iOS with the Xcode project set up already. So this is like a monorepo approach where you have all in one project 3 folders with shared code, iOS, and Android. So now let's move to the actually things that are, I think, interesting here, and maybe something that is might make you wondering how to use this in your project. So for the sake of this presentation, I prepared really simple example with implementing the logging view. So here I think there are white on white username and password text fields and a button, and then when you provide the credentials, it should go to the a screen with your user, right? So the disclaimer is that the code that you will see is a bit, let's say, less optimal than normally production code you would write, because I wanted to don't put as less code out possible, so it's easy to read. And there will be an example later on shared, so we can actually see how you can run the code. Of course, the ideas presented here is not an ultimate solution. I'm not saying that this is the ideal and you should all go do the same way, but more like inspiration on how we can do this, and maybe how on the beekeeper side, based on our experience, how we would go with that. And lastly, don't be scared about Kotlin. If you haven't seen this, it's mostly looks like a Swift one. So what we will to recap, we have this login view with 2 text fields and a button, and we would like to enable the login button only if we have at least a username and password provided, right? So we would start with view model, right? The beekeeper, we would go with the MVI. Anyone heard about MVI pattern? All right, so at least one person. Basically, it's nothing really complex. The I stands for intents. So basically, you send intents to your view model to reflect some changes. You can send objects as an intents, but in our case, intents are just methods on the view model, right? So this is mostly like MVP, let's say, but there's a state that is immutable provided to the client side. So our view model has state, and it's provided as a flow, which is basically, anyone knows Rx Swift or things like that. So it's basically like a stream of observables that you can register, subscribe. So if you start collecting, it will provide you the next values, right? And same goes for events. It's also a flow. And event is something for side effects that may occur during actions with your view. So state represents the immutable state that will try to modify when we call this intents, and events is something that happens on the side, like a side effect. So here we have 3 intents. One is for updating the username when you provide something in the text field. We have, of course, password, the same thing, and perform login, which will wire to the button. So the next thing is the login view state. So something that will represent the state of our view that we would like to render on both clients. So here we will use the Kotlin's data class. Basically, it's a structure that is used for holding data, and it's basically it's a reference type, but you can also think of this as a, let's say, struct, in a way that it's automatically generates this equals and hash codes and other things and other basic methods implementations. It's immutable by default, and basically it's concise, so we can easily define the properties. And our view state will be composed using the sealed interface. Interface in Kotlin is protocol in Swift word, right? So bear with me. And sealed interface basically specifies the possible implementations of this interface in the same file, right? So here we define the partial login view state interface, and then we know that there can be only 4 concrete implementations of this interface, and and for that we decompose our view state, that there is a portion that represents just the username text field, password, if the login button is enabled, and the state if we have or have not user, right? Basically the sealed interfaces allows you to, I think it's I already said, but just repeat. So we restrict the implementations. In the same file, we defined all the possible implementations. And what is actually cool is that we can use the when expression, which is similar to switch, where we can, on the compile level, we can switch between all possible implementations. So it's more like construct, right? So coming back to our view state. So now this is how it would look. We have 4 properties that represents the portion of the state that only reflects the username, the password. if the login button is enabled, and if we have a user, right? So right now we only define the view state, and now the part that we need to change this view is the state reducer, and this is the object that have one public API and takes the immutable view state and the partial view state, so the portion that we would like to change, and we are using this when construct to actually change only this one portion of the state and return the copy with the updated. So for example, we can call this method to update whenever user provides username in the text field. We will call this method with the partial state for the username, and then we will end up in the first branch here and return the login view state with updated username partial view state. So the reducer is like a central point for updating the login view state. What else? It's what we do is we take the current view state and basically apply the changes. All the modifications on the view state happens within the reducer. And as I mentioned, we also need a view event. So this is like a side effect. So for example, here we use the class, not the SILT interface, because sometimes we want to have like generic events like dismiss that can be shared across the different views, and then we can have like a subclasses where, for example, for the login view, we can after login we can ask for tracking permission, for example. So there will be like a side effect during this this process. So that's that. Let's jump into implementing the first intent that we can have in our view. So the methods that you've seen at the beginning was update username, and here basically we take the username parameter from the method, and we have this set view state method that I hidden the implementation here, but basically what it does, it takes the view state reducer state that was updated, and then it propagates this to the anyone that subscribed to the flow. And basically when you call the update username, what we do two things is to update the partial state of the username, and secondly we update the if the login button should be enabled based on this credentials is valid method, which is checking if username and password was provided. So basically what happens here is that we have this reducer that updates the immutable current state and only update the username and the login button enabled. When it comes to the performing the login, I skipped the part where I implement the API call. Let's say it's a homework for you guys, and then let's say that we already implemented all that. Maybe this is a use case, or it's a use case coming from outside, or use case implemented in the KMM. But in the end, we would have like user object with ID and display name. And again, what we will do is call the reducer, and on the current state we would say, okay, we have now logged in user, and we have another additional method at the bottom to basically also emit the event to ask user for tracking permission, right? So this is all the Kotlin code that I will be showing today. So sorry for that if you are expecting more iOS code. One disclaimer on the iOS side is that in order to observe this view model in Swift UI world, there is some work to be done. And in my example repo, you will see this protocol, which basically you can extend our login view model coming from the shared code by providing state and event types, and basically it will allow you to make the observable object from our view model and then embed it in our Swift UI code, so we can then respond to changes and render the UI whenever something changes. I also recommend these two tools. One is for actually making the view models observables out of the box, so you don't need to use the code that I have in my repository. And also this Ski Swift Kotlin interface enhancer from TouchLab is really nice. They add many support things like default parameter values for methods and things like that. So definitely worth checking. So iOS time, we are back to iOS Word. So the first line is actually from outside we got our view model, and as I mentioned, we have this extension so we can mark it as observed object. And the UI is pretty straightforward. We have a vertical stack with text fields, secure field, and button. And here we can see how, for example, we can have a binding for grabbing the current username from the view model and sending the intent to whenever something changes in the text field to notify our view model, and then it will propagate the change through the this intent that reducer will update the current state username, and then will inform back the clients. Also, the button calls the perform login intent, and we are controlling the disabled state of the button also using the current state logging button enabled, right? So here we wired the view model from the shared code to the text field, and the button I skipped the secure field because it's the same as a username. So that's that. As I mentioned, we have these flows, this asynchronous stream of data that we use to communicate state changes and event changes. So for example, on appear closure, we have to start this collecting these state updates and collecting the events. So here, for example, we can have some checking if we should show the tracking permission, right? So this collect state is coming from this extension that I showed before, but basically we are registering, like subscribing to the flow. So like in RX Word, you would just subscribe and add it to the disposable bag, right? So basically that's starting the subscription here. And also here is the part where we would like to show another screen. So in this case, user details view based on the logged in user partial state. So whenever we actually got the user from the API, we reduce the state so it now contains the user, and then based on that we can present the user details view. So all this example is in this repository. In the shared src command main is the shared code with the view models, the reducers, the view states. So I encourage you to check and submit pull requests and whatever you'd like to do. Hate me or submit issues, or we can work on this. There is on iOS there is app folder is a SwiftUI app. On Android there is not much there, so if anyone wants to contribute, more than welcome. So this is how it looks. Damn, it's white on white again. But yeah, so basically, it's like we control the login button state, right? But when you press, it just presents some, hard-coded data. So this is the working example where we have the view model, we have the view state, and whenever you interact on the SwiftUI part, we notify our view model, it updates the state, and you can actually also on the client side respond to the state changes, send the intents, and presents the UI based on that. So a couple of tips based on our experience is to definitely start small. It's not like go all in and jump to rewrite all the projects. Ideally, you can select screen that you have already onto platforms and migrate this to the shared view model, because then you can easily have a verification if your new shared model is actually doing what it should be doing. So it's like a clear indication if you're doing if there are no regression bugs. The very cool construct in the Kotlin Multiplatform is actual expect actual. It allows you to annotate interfaces, classes, or even single methods that should be provided by the implementation by the clients. So this can be implemented already in the Kotlin Multiplatform because there are mappings for the APIs from iOS Word already in the Kotlin. So, for example, foundation methods for dates, for file manager, things like that are already mapped in the Kotlin. So you can have the platform-specific implementation already in the shared code. if it's not possible, then you can delegate implementation to clients, so declare interfaces. So there are like 2 levels of ways of providing different implementations depending on the platform. The next steps, I would say, would be to try to introduce API calls. Those are basically possible ideas for evolution whenever you confirm that it's something that is working for you. You may, for the API calls, you may still need to pass, some auth headers from keychain and things like that, or so there will be some communication from clients to the shared code in order to make these API calls. But what is cool is that Ktor, for example, has the built-in response serializer. So any JSON responses that you have can already be serialized to DTOS objects and then to the main objects through your use cases. So your shared view models may actually do all the work, and the models won't even escape the shared code. So on the iOS and Android side, you only interact with the view models and sending intents and responding to state changes. What is really one thing that we learned our lesson hard was using the Realm KMM, because we also use that on iOS side and Android side as well. And on the iOS side, there was some weird crashes because the iOS Realm relies on Realm core C++ implementation, and the KMM version as well has this like a dependency. And if those 2 Realm cores are running the same time, there are some weird stuff happening on. So what we did, actually, we use SQLDelite for now on iOS for the shared code. So our persistence layer is in the SQLDelite due to these crashes. But maybe it's Beekeeper specific, I don't know. But just something that is worth keeping in mind. Lastly, I would definitely recommend this talk from DroidCon last year. That's from our Android team that were there in London. This is something that the link is in the slide, so we can click afterwards. So basically there the author describes how we can write Kotlin code, which is like a iOS friendly after translation. So as you remember, Kotlin Multiplatform goes through the Objective-C to the Swift. So there are some nice tricks of writing Kotlin code that is more like iOS friendly. So that is definitely worth checking. And one last topic is breaking changes. So whenever you start sharing code, right, there will be a new domain of problems where one team changes something, right, and then other team pulls the changes, and then it's not working, right? So I think it's vital to already address those changes, issues. So for example, require from the both teams reviews of the pull requests, and have like ways of process of resolving these breaking changes that are coming from the pull requests from other teams. So I guess the communication is the key part here. All right, and special thanks to my colleagues from Beekeeper Android team, Mateusz, Artur, and Andrea. If you're watching, thank you guys. Without them, I wouldn't be able to do this talk, because I'm an iOS developer and I learned a lot from them. So thank you guys. And that's it from my side. And if you have any questions, I'm here to answer them. Yeah, so that's a great question, and so I'll repeat because it needs to record. So the question was how to deal with network layer whenever we have already them implemented in both clients, right? And then in the shared code, you would like to use that network layer inside, right? So it's like a dependency from the clients to the shared code. So that's a great one, and I don't think I will have a great. Maybe after networking, we can talk about this. But I would say that it may be better to inverse. Like in our case, most likely we, for example, implement use cases in the shared code. So for example, in the login view, we would have like a login user use case, right? And of course, it has to make an API call. So right now we are making the API call inside the shared code, but in our case, maybe in your case, instead of just like sucking in all the network layer, just like expose like a use case that can be injected to the shared code. So as opposed of integrating all the network layer, all the stack that you need, maybe just like try to isolate the single requests in form of use cases that can have a simple interface, like use case can have just invoke and login user or whatever, and then this would be like a smaller dependency for the shared code. So I'm pretty sure it's not an advice you were seeking, but actually it's something that lets you move forward, right? Without all the problems that you said that you have to have this full context loaded, right?
I was just curious if you stumbled across the challenge.
Yeah, of course. We try to actually to circumvent them by actually decomposing to smaller chunks possible, as opposed to like trying to import all the stuff that you already have in the project.
Right.
So question was, how do we handle tests and mocks? So you're asking about mocking the shared code, or
only shared.
so this is actually a good part, because this is Objective-C, right? As I mentioned, so we can use the old Objective-C frameworks for mocking, so like Mockito or CMOC, because those are really the Objective-C types. But what is actually cool that I stumbled across recently is that there's a tool from Uber called Mockolo, and it's really nice because you can annotate just so it builds on the premise that you use a lot of protocols and interfaces, and basically you annotate the protocol or interface by just Mockolo, and then during the build time it automatically generates the mocks with all the tracking the call parameters and things like that. So I would say that either use mocking libraries for the Objective-C, or use tools like that allows you to generate the protocols for the mocks. All right, so the question was, what would be the advice for the iOS developer if he would like to start working on the Kotlin side? Do you have any Android teammates, or you're just like by yourself and you would like to just know the other platform? What is your use case? Okay, cool. So in my case, for example, in the case of previous company, I was basically, the code reviews and the pull requests is really nice way of starting to, getting the feedback about your code. So right now at Beekeeper, both iOS and Android team is actually contributing to the shared code. It was not imposed by, like a hard rule that everyone has to do this, but it was like organically happening, because over time, you start with small pull requests and then you rely on your colleagues that they will actually provide a meaningful code review, right? So with that, I would say with these baby steps, try to maybe first add some small intents and then try to add a new view model for the sake of learning. So I would say iterative approach for sure, and relying on your kindness of your colleagues from your Android team.
But if you're alone?
If you're alone, JetBrains has a really nice tutorials for the multi-platform apps. There is like an app that uses Ktor and SQLite. I can send you the links, or we can talk about this later. There's a great example where you can actually see how you can share the view model, make an API call, and store some data already in the KMM, and have the native UI differently. So the only part you would need to find is the Jetpack Compose for the UI for the Android, right? The question is about the Jetpack Compose, the UI framework, right? So right now. It's still on alpha phase. I saw some blog posts from JetBrains, and it looks, promising. I would say that, I think it depends on the use case. I think it's tempting at least to check for like a simple views, non-complex, maybe that are not really flashy with animation, because it won't be iOS native framework. But I guess there is a potential there, but I would be cautious because it's still not a stable iOS version. On Android side, I think, and on web, I think it's a preview stage. So it will be probably, I guess it's a matter of time when it will be stable. So definitely, maybe it's worth to at least try this out. But for now, it's not a production material, I would say. Okay, that's it. Thank you, guys.